In this example, we illustrate how to use superposition method to obtain V0 and I0. We know from Ohm's law that V0 equals to this resistor, that's 10 ohm multiplied by I0. So once we find V0, I0 can be obtained easily using Ohm's law. To apply superposition, we need to turn off these two independent sources one by one. The first step is to turn off this voltage source. That's 30 volts voltage source. To turn it off, we need to short circuit this branch. So this here is short circuited. And this current source still here. And pay attention that controlled source, we do not do anything about it. Pay attention to the notation change. This is I0. The current is 4 I0. And here that's a branch current in this branch. And this is 4 I1. This is a bigger I1 and small I1. That's the same thing here. So our task is to find V1. Is the voltage when we turned off this voltage source and this current source acting alone. To solve this circuit, we can use nodal. There are two nodes here, VA and VB, and the reference node is here. To apply the KVL on this node VA, we have the incoming current stack 6 and out current, that will be VA divided by 40, and then VA minus VB divided by 10. That's first equation. The second equation we have the current flow into equals current flow out to. Current flow into, we take negative, that's minus I1. And current flow into, that's minus 4 I1, that's from this controlled source. And this current flow out, that will be this direction. This current flow out, that will be VB divided by 20. And minus 0, which means that the voltage at the reference node, that's 0 volt. Therefore, we obtain two equations, and we know an I1 equals to VA minus VB divided by 10 from Ohm's law on this resistor. So we can solve VA and VB. After we solve VA and VB, we have V1 equals to VA minus VB. So that's the first portion of superposition. The second portion is to turn off this current source and apply this voltage source alone. To turn this current source off, we open circuit. So the circuit becomes only this portion. We redraw this circuit here. Pay attention that we do not do anything for the controlled source. So this is current I0, and this is 4 I0. So the voltage, we named it V2. So we can use nodal analysis. There's only one node here. There's a current flow into this direction, current flow into this direction. Reference node is here. And this is a 40 and 10, as these two resistors are in series, so total that will be 50 ohm. This is 50 ohm, as a 40 ohm in series of 10 ohm, that's 50 ohm here. The directions of I0, that's this direction. Here, big I0 and small I0, that's the same. The nodal analysis on this node, we see current flow into, that will be I0 plus 4 I0 equals current flow out. Current flow out in this case is equals to VC, that will be minus 30 and divided by 20. And I0 equals to negative VC divided by 50. And this is exactly the equation we obtained. After we obtain VC, we can obtain I0 V2, that's the voltage. V2, that's the voltage on this 10 ohm resistor. The direction of I naught, that's this direction. The sign of convention is followed. So V2 equals to 10 multiplied by I naught. After we obtain V2, V naught equals to V1 plus V2.